All right, so getting this one set up, to solve it, I'm going to go with 3.75 divided by, because 159.8 is on the bottom, so I'll divide it. All right, my calculator gives me all these digits, 0.02346668. How many sig figs should I give for my final answer? Yeah, just 3. So 0.0235, I think, will be our final answer. With a unit of moles, and I'll even be specific, it's moles of bromine, moles of Br2. And then I'm going to let grams and grams cancel here. So grams cancels with grams. That's why my final answer ends up in moles. Is the glare bothering anybody really badly to the point where you can't see well? I'll go ahead and it'll be kind of dark in here. I think your calculators will work for a while though, since they've been in the light most of the morning. All right, so that's our first one, going from grams to moles. Let's try it with the next question. All right, it says convert 50 grams of NaOH into moles. So the first thing I need to do is find my molar mass of NaOH. So let's add those together there. Na is about 22.99. I only have to have actually I only have to have 3 digits, but if I have a 4th digit there, that's fine. Plus oxygen is 16.00 plus hydrogen 1.01. What do you get when you add those 3 numbers together?
39.99.
Yep. And then that rounds to 40.00. If you went with more digits than I did and you did 39.998, you're going to get just as good of an answer. As long as we have at least 3 sig figs. Here we've got 4 and 5 sig figs, so we're totally safe. All right, then we're ready to set it up. We write down what's given, 50 grams. We do our times in a line. And then we're going to use the molar mass as our conversion factor with grams on the bottom and moles on top. On a conversion factor for this chapter, or this unit that we're studying, one will always go with moles, and then something else will go with the other. In this case, it's molar mass here. Now, if I've got 50 grams, and the molar mass says it's 40 grams for 1 mole, should I get an answer that's more than a mole or less than a mole? More. I've got more than a mole, because a mole would just be 40 grams. I've got 50. My calculator says 1.25. How many sig figs do I have to have in my answer here? Yeah, I should have 2 sig figs because I started off with the 5 and the 0. That's 2 sig figs. So what would that round to? 1.3. That's 1.3 moles of NaOH for my final answer. All right, on this last one here, I want us to pay attention to our sig figs just a little bit more. Before we move on, does anybody have any questions on that? Riley?
So like for the molar mass, where do we get like all the 3 sig figs from?
Oh, so I need to have at least 3 sig figs in my molar mass. The numbers that I got had 4 and even Wilson didn't have 5 sig figs. I'm safe. If I use 4, 5, 6 sig figs, I'll be safe. But if I try to solve this one, or this one would have worked out anyway, so it's exactly 40. But on some of them, if you just round to like the nearest ones place for your molar mass, you won't get an accurate final answer.
So no matter what, the molar mass always has to be at least 3 sig figs.
It needs to have 1 more digit than what's given to you in the problem. So you're asking a great question. All right. This problem started off with 50 points. That has 2 sig figs. That means my molar mass needs at least 3 sig figs. On the first problem we did, the given was 3 sig figs, so my molar mass needed at least 4 sig figs. That last one's called a safety digit, and that just means that I have something to round to at the end.
Okay.
And we'll all be rounding to our same final answer if we stick with our safety digits. Yeah, you're welcome. That's a great question, and it leads into this next one. Because on this next one, we got to really focus on having our significant figures in our molar mass. We're going to convert 145 grams of NH4 2S to moles. Same idea as the last one, but molar mass, we want to make sure we have at least enough digits. So this question starts off with 3 sig figs. That means my molar mass, to have a safety digit, I need to use at least 4 sig figs when I put these together. Just to be safe, so when I deal with nitrogen, finding this molar mass that I'm going to put right here. All right, nitrogen, there's 2 of them. So I'm going to say 2 times 14.01 plus hydrogen. How many hydrogen atoms are in this compound? 8. So I'm going to say 8 times. Hydrogen's a little bit weird because to have 4 sig figs with it, I might actually want to go all the way to 1.007, I think is what it says. So dim in here. 1.00, actually 1.008 is what that would round to. That'll make sure that I have a 4th sig fig. And then sulfur is 32.0. I just can't see it from back. 7, thank you. So most of the time we're safe going to the 100th place, and you would still get a good enough answer, I'm sure, if you use hydrogen as 1.01. But the sig figs rule would actually encourage us to have that extra safety digit with it. All right, that's 68.15. There's my molar mass. Now I'm ready to solve this problem. I'm going to write down what's given and then do the conversion factor for it. 145 grams. When I'm converting to moles, moles goes on top, grams goes on the bottom. I'll use the 68.15 molar mass. Grams and grams will cancel. I'll divide 145 over 68.15. And that's going to give me, should I have less than a mole or more than a mole for my final answer here? I should have more than a mole, right? Because I have 145 grams. 1 mole is only 68 grams. I want 3 sig figs. So my calculator says this. There's my first 3 sig figs. The 7 tells the 2 to go up. So that's going to be 2.13. And what's my final unit here? Moles of that substance, because I was converting it into moles. All right, so on that side, we're going from grams to moles. We're going to flip this worksheet over, and we're going to flip our conversion factor over, because we're going to go from moles to grams. Moles to grams, I think, is even a little bit easier, because it really emphasizes what the molar mass is all about. Almost the same setup. Your conversion factor is just going to be flipped. We're converting from moles to mass, like you see up there. Yes, sir.
So, here's the last one. Sorry.
Yeah.
I got 36.08. How did you get the other 30 on?
For the molar mass,
Yeah.
how many nitrogens did you have?
I had
So how many hydrogens?
8.
How many sulfurs? Sulfur, yeah.
Yeah, I didn't see something.
That's it. That's the most common problem with these, that people know how to do them. It's your molar mass. So sometimes if I come around and you have a wrong answer, and I'm like, you need to check one, first thing you should look at is your molar mass. You might have to go back and do that again. On these, we start with given number of moles, and then we've got our conversion factor. So what I mean by conversion factor, whoops. That conversion factor, we put molar mass on top over 1 mole of a compound, or it could be an element on the bottom. So find the mass of 4.52 moles of this compound's called octane. When you get gasoline, you might see that it contains octane, and that's what that is. It's 8 carbons. That's why it's octa. All right, so we're going to find our molar mass, 8 carbons, and 18 hydrogens. Once again, just to be safe, I'm going to give myself 4 digits with my molar masses. That'll make sure that I'm going to have plenty of sig figs in my conversion factor. And that gives me 114.2. If you want to go with more sig figs, that works, but you need to have at least 4 sig figs. Use extras if you're not sure. Grams per mole. So it's 114 grams for every mole. I have 4.52 moles. Now when we're solving problems, we want to make sure we're starting with moles here. So that means moles needs to be our unit on the downstairs of this conversion factor, otherwise it won't cancel. And we're converting it into mass, which is grams, so that's why grams goes on top. Well, your molar mass is your grams for every 1 mole. So I'm going to put 114.2 grams over 1 mole. 1 goes with moles in conversion factors. And then we're ready just to multiply this time, because 114 is on top. My calculator is going to do 4.52 times 114.2. Thank you. And just so I can go through that, did your calculator initially say 560, or did it say something else at first?
No, I said 516.
516, thank you. Yeah, so my calculator's got all these digits in it. And we look at 4.52. That's got the 3 sig figs in the first place that we started with. So I need just to round it, like you said. 516. What's my unit going to be this time? Grams. This time grams. Moles cancels. We're converting to mass. And there's what we'll get there. 516 grams of octane. What do you think about the next bullet point?
I think we could just multiply it by, we could just multiply the given mass by 3.
By 3. Yeah, the molar mass by 3, right? What's the mass of 3 moles of carbon? This kind of just circles back to what we talked about at the beginning. On your assignment, I want you to show your work with the dimensional analysis. But look, this is what it's all about. 1 mole of carbon was 12 grams. 2 moles of carbon was 24 grams. 3 moles of carbon is 36 grams. So that's what it's all about. So for this one, if we just think about this one proportionally, it's fine with me if we just go ahead and kind of get that idea down. Let me scroll here. On your assignment, I'll definitely want you to show your work, but just for this one, it's made to be kind of friendly like this. 1 mole of carbon was 12.01 grams. 2 moles of carbon, this is what the molar mass is all about. Let's double that. So 3 moles of carbon. And then I'll just take it to my sig figs, 36 grams of carbon. So if you can think about it proportionally and get an answer, I prefer that just as much as the dimensional analysis or something like that. On the next one, it's got a more interesting molar mass, so we'll definitely show our work again with the setup as before. I'm going to have you do that one on your own before I have to start you on the assignment. The mass of 3 moles of carbon tetrachloride, just to make sure we're all on the same page, it's been a while. What's the formula of carbon tetrachloride? For what? CCl4, okay. So I want you to try this one on your own, but I want to make sure everybody gets CCl4 right. And then once you get that, the last thing I want to talk about is volumes of gases. So far we focused on the mass and how you can go between mass and moles based on the molar mass. And it makes a lot of sense if you just remember what molar mass means. It's the mass for every 1 mole. With gases, sometimes we want to keep up with the volume. Like if you had this balloon, and you knew this balloon had 1 mole of carbon dioxide, it turns out with these gases we know how much space a mole takes up. No matter what the gas is, whether it's carbon dioxide or oxygen gas or nitrogen or anything, if you have 1 mole of it, even though the mass would change, the volume is always 22.4 liters. That's a big balloon. When you're at a certain temperature and pressure. All right? We talked about gases in this class at the beginning, and we learned like if you increase the temperature, that balloon's going to expand. If you decrease it, it would contract. If you increase the pressure, the balloon would contract. So we need to make sure we're dealing with the right temperature and pressure to make sure that this conversion factor of 22.4 works. That temperature and pressure where this number works, in science it's called standard temperature and pressure. So I'm going to write that on that notes page. That's the first thing. STP stands for standard temperature and pressure. And basically it just means that, yeah, we're allowed to use 22.4 as a conversion factor. It's a very specific temperature, but it's an easy one to remember. The temperature is going to be 0 degrees Celsius. That's the same thing as 273 Kelvin. And the pressure is even easier. Pressure is 1 atmosphere. So it's basically standard conditions at the freezing point. And they chose that because even in the old days before they had like good refrigerators or heaters or something like that, if they wanted to get 0 degrees Celsius, they just made ice water. So if you get ice water and you stir it up, that's 0 degrees Celsius. So that made sure that any laboratory around the world could really easily make 0 degrees Celsius. And 1 atmosphere of pressure is the typical pressure when you're at least at sea level on an average day. So we call that standard temperature and pressure. That means that 1 mole of any gas, whether it's carbon dioxide or anything else, is exactly 22.4 liters. So we can use that as a conversion factor like you see here. Either 22.4 liters over 1 mole when you want moles to cancel, or 1 mole over 22.4 liters when you want liters to cancel. So it kind of depends. Are you going from moles to liters, or are you going from liters to moles? One thing you got to keep in mind is your volume unit has to be liters to use this amount. If you've got milliliters, it's not going to work. You have to convert to liters first, and we'll see that on an example coming up. So let's look at a few examples on here involving these conversion factors. And these go along with the 3rd page of that packet. This is kind of the same kinds of problems you'll be doing on the 3rd page of your packet. First one says, convert 4.5 moles of CO2 gas, that G, excuse me, when the G's in parentheses like that, it doesn't mean grams, it means gas. That's just a reminder of gas. To liters. All right, well, same idea. Write down what's given, 4.5 moles. There we go. 4.5 moles, that's 2 sig figs. And these are great because in some of these you don't even have to worry about a molar mass. if I start with moles, I need moles to go downstairs so that it's going to cancel. I need to convert it into liters. So there's my conversion factor up on the top of the worksheet or the notes page. 22.4 liters for every 1 mole. So 4.5 times 22.4. And that's going to give me, my calculator says 100.8. That'll be liters, but I want to focus on sig figs still. I'm going to hit the lights just so you can see the screen better. Still want to focus on sig figs. How many sig figs are in 4.5? There's 2. There's a couple ways to do it, but I need to somehow get this to have 2 sig figs. Well, right now I've got 4 sig figs. If I said 100 point, that would have 3 sig figs, so that's not going to work for me. How can I write that number with 2 sig figs? Well, there's 2 ways to do it. One is you could put 100 and put a line over it. That line over the 0 means that I have 2 sig figs. Or you can use scientific notation. That's the more modern way to do it, is with scientific notation. The older way was to use the line, but I like the line version better because it's just easier to keep up with. That line over the 0 does not mean repeating. A line over a 0 like that means this is a significant 0. And that's 100 liters of carbon dioxide. So I should put CO2. You don't see that happening too often, but if it ever does happen, that's one way to mark a 0 as significant without its neighbor being significant. All right, then we've got the next one on here. So the next one I wanted to do, just to remind you that if you're starting with anything other than liters, you got to get it into liters first. This one says, convert 350 milliliters of argon gas to moles. You must convert to liters first. So I'm still going to write down 350 milliliters. If you can do the liters to milliliters or vice versa in your head, that's okay with me too. But the way I'll keep up with it, if I want to show it, if I start with milliliters, and that means milliliters needs to be my bottom of the conversion factor. I want to put it into liters first. And then I'll use a second conversion factor to go from liters to moles. The one in green is going to be the 22.4 one that we've been practicing with. But this just reminds us, with this dimensional analysis stuff, it's always that pattern of our units canceling. Who remembers how many milliliters are in a liter? That's a good question. Is it 100 or is it 1,000? It's one of the two. It's 1,000. You got it. We want to remember that. 1,000 milliliters in 1 liter. That's going to be our first conversion factor. And then on the second one, how are moles and liters related? We just learned about that number. 22.4. Is it 22.4 moles in 1 liter or the opposite? It's the opposite, huh? 22.4 liters, so that goes with liters, is 1 mole. Now I'm ready to do this. As I work through it, I can see that milliliters and milliliters cancels, liters and liters will cancel. That was the whole point of setting that up. And then I do the operations. 350 divided by 1,000, and then divided by again, divided by 22.4. Divide by numbers on the bottom, right? Now I got a small number here. Remember, it takes 22.4 liters to make 1 mole. Well, this is only 350 milliliters, so it's a lot less than a mole. That makes sense that it's a small number. How many sig figs should my final answer have? 2. So just as a reminder, it's going to be 0.016 moles Only the 1 and the 6 are significant. That first 0, that's a placeholder. It's been a while since we practiced with those. And that's argon gas. So the last one on this worksheet is kind of my favorite one because it really shows kind of the importance of the mole. The idea that the mole can be used to interconvert between all kinds of things because it gets all the way back to the particle. On the last problem, we're going to interconvert between volume and mass using everything we learned about today. The 22.4 and molar mass. Let me scroll down. So it says convert 2 liters of nitrogen gas to grams. So this time we're starting off with the volume, which is liters. And we need to get over here to mass. So if I look at this roadmap, it can help me out. I'm going to do 2 conversion factors here. I've got to use the 22.4 liters as a conversion factor to get to moles. And then I can use moles to get to mass, like we did at the beginning of class today, going from moles to mass. Still going to set it up like before with conversion factors. We write down what's given. 2 liters of nitrogen gas. Just put 2 liters there. All right, my first conversion factor. What should go on the bottom of my first conversion factor? Liters. I can't go straight from liters to grams, but I can go from liters to moles using the 22.4. And then I'm going to have a second conversion factor. What should go downstairs on my second conversion factor? Moles. And I can convert that into grams because I know how to deal with molar mass. So in the first one, I'm going to put 1 mole is 22.4 liters. And in the second one, I'm going to put 1 mole is the molar mass of nitrogen. Well, that's going to be 2 times 14.01. That's from the periodic table. And that's what's going to go there, 28.02. So that's how you can deal with something where you go from volume to mass or mass to volume for these, at least for gases. So I'll say 2 divided by 22.4, and I'll multiply times 28.02 since it's up on top. So I'm going to get 2.5. What's my final unit going to be here? Grams. Grams of nitrogen. So that's cool. I could know the volume of the balloon was maybe it was a 2-liter balloon. And I could use that to predict what the mass of the gas inside of the balloon would be. So you'll use those kinds of conversion factors on the last page of excuse me, of the worksheet. They start off a little easier, like the first one on this example. And by the bottom of it, you'll have to throw in some molar mass stuff on there.